So they say they found microplastics in breast milk. This was reported by The Guardian a couple of years ago. Microplastics found in human breast milk for the first time. There's not a lot of detail in this article, just a statement that 34 healthy mothers provided samples and 75% of those were found to have microplastics in the milk. There are some quotes from one of the authors about concern for the health of the babies and some statements that it's probably still better overall for your baby to breastfeed, even though there's this additional risk of exposure to microplastics. So let's go to the article and see what they did. This is a scientific article found in the journal Polymers, reported about a couple of years ago. Right here in the abstract is what is stated in The Guardian. Microplastics found in 26 out of 34 samples from new mothers. So the Guardian reports what the scientific literature reports. This article has a lot of analysis about risk factors, exposures, that kind of thing. But really, before there's any interest in that, you should be certain that your findings are correct. So let's first see if we're sure that the microplastics were actually in the breast milk. This description, I'm not going to read all of it, but basically they took a lot of measures to make sure that no microplastics from the surrounding environment got in. They wiped down all the surfaces. They had filtered air in a hospital environment. They used non-plastic equipment essentially everywhere. Didn't even use a breast pump, which has plastic components, so the milk was expressed by hand into a glass container. So they took a lot of steps to avoid exposure from the environment. But one surface I noticed that they don't mention cleaning, and I have contacted the authors for comment, and also I've contacted the editors with the analysis that I'm going to show you here, and I have not received any replies. So as far as I know, they took no steps to clean the surface of the mother themselves. So our skin has been shown in other studies to have some microplastics adhering to its surface. That includes all of our skin, including the nipples of new mothers. So it's quite possible that a few microplastics were lodged into the pores of the nipples, and as the milk was expressed, the microplastics were dislodged and they were collected and treated as if they had been in the milk. So I thought, is there any way to take the data that they have and see if we can determine whether this is the case or whether it was actually in the milk? This is the key to determining what the actual origin of the microplastics is. So they took a range of sample masses from 4 plus or minus about 2. So about 2 to 6 grams of breast milk. So you have these differing volumes, differing masses of samples. And if the microplastics were in the breast milk itself, you would expect a general trend. There's going to be a lot of noise, but you would expect a general trend that the higher volumes of milk would contain more microplastics, right? There's no reason a priori to think that the larger samples of milk are going to have lower concentrations of microplastics. So that data is tabulated here in Table 1. This is all the data we need. This is just the first page. All 34 are listed. So the milk quantity and the number of microplastics, that's all we need to really find out where these actually came from. So let's just plot this data. This is a plot of their data in Excel. You can see we have milk expressed on the x-axis, and you see it's 4 plus or minus 2 with some outliers. And then microplastics found, and they range from 0 to 5. And you can see here the slope is very close to 0. In fact, it's slightly negative at minus 0.12. So there seems to be no correlation between the volume of milk expressed and the number of microplastics. So I thought about how could this possibly be? Could it still be microplastics coming from the breast milk? And the only argument for that I could think of is that there's just such a low number of particles found that it's just a random occurrence that in this data set there happens to be a lower number of particles per gram of milk for the larger samples gathered. So I tested this, and it's a fairly straightforward thing to do. It's something called a Monte Carlo simulation. So this is a Monte Carlo simulation, assuming that the particles are found in the breast milk. So this randomly assigns every particle to some tenth of a gram of milk because there's no a priori reason to expect it to be in one spot preferred to another. And if you do this for all 58 particles, you can generate this random graph. And in this case, the slope was 0.42. And I'm going to just sort of cycle through a few. 5, 0.35, 0.3, 0.41. So I did 100 of these, and I averaged the slopes. And I don't think any of them ever got close to zero. But you can see there is a wide variation in slopes because there's such a low number of particles. The data is noisy. It's going to be noisy. But the slope is never really close to zero. So then I did the opposite. I said, well, let's assume that the microplastic particles don't come from the milk. They come from somewhere else, and most likely the surface skin of the mothers. Okay, so this is a separate Monte Carlo simulation. This is assuming for every particle, it is on a random mother. Okay, so not in a random place within the milk. It's on a random mother because, again, there's no a priori reason to expect one mother to have more particles stuck to her than another. So this is a simulation based on an external contamination, and in this case, coming from the mother herself. So here the slope is 0.19. I'm going to cycle through a few of these again. Slopes are close to zero, sometimes a little positive, sometimes a little negative. Always very noisy data, as you'd expect with such a small data set, such a small number of particles. But again, the slopes are close to zero, which is what would be expected. And again, I did 100 of these and took the average slope and some standard deviation. Okay, so this is a summary. One hypothesis is that the microplastics come from breast milk. The expected slope in that case is 0.39. That's the total number of particles divided by the total number of grams of milk. The standard deviation was 0.14. The observed slope is 0.12. That's well over 3.5 standard deviations away. The odds of that happening are very low. I don't know, 1 in a million, something like that. It's very, very low chance that you're going to get a slope of negative 0.12 from this hypothesis. The second hypothesis is that the microplastics are dislodged from the nipples, the surface of the skin, as the milk is being expressed. The expected slope based, ideally it's zero, but based on the 100 Monte Carlo simulations I did, the average there was minus 0.02 with a standard deviation of 0.13. So this is within one standard deviation, so it's a reasonable fit for this hypothesis. So the conclusions are, once again, that microplastics are not found in breast milk in this study. There's no evidence for microplastics in the breast milk in this study. They were most likely dislodged from the pores of the nipple. They could be from some other source, but the most likely case is that they were just on the mother themselves when they came out. So should we be worried? I mean, this is still some small number of microplastics that the babies are exposed to every time they breastfeed. I don't think so. I mean, the most likely fate of those microplastics is that they are going to end up in the baby's diaper within a very short period of time. If there's one thing that all babies know how to do when they're born, it's poop. And pooping is really the only skill they need to take care of this problem. There's all kinds of exposure to all kinds of contaminants, and that's why our bodies have these systems that remove the contaminants in our pee and our poop. Okay, so I really don't think there's anything to worry about here. So this is yet another article where they didn't really consider all the alternatives. They just found some microplastics and made some assumptions. This is okay. This one's a little more subtle than the blood paper where they had duplicates that weren't confirmed. But yet again, this is a widely cited paper with really no support for the conclusions that they present in the paper. Thanks for watching. There's more to come.